Through is the UV sterilizer, and it's a chamber back there where if you've ever been to the beach and gotten sunburned, the wavelength of light that burned you was UVC. And UVC is it can give you skin cancer if you get too much of it. That's why we have to put on sunblock. So this filter has a bulb in it. It's called a germicidal lamp, meaning it kills germs. And as the aquarium water passes through the UV sterilizer and it gets exposed to that chamber of very bright light, you can see the end of the UV sterilizer is glowing green because it has a blue plastic plate over it. And as the water goes through that chamber, any waterborne pathogens such as bacteria, phytoplankton, green water, anything that would take away from the clarity of the water, or any pathogens that could cause, like parasites. The larvae of the parasites can be killed by that UV sterilizer. So it's a great preventative for preventing disease from getting out of control. And then the water goes back to the aquarium, overflows back, and on its way overflowing back to the sump, it goes through this drawer. It's a drip plate. I don't know, can you see that very well? Mm-hmm. So this drip plate, and then the water falls down into this shredded plastic media. The drip plate, the pre-filter pad is to catch fish turds and uneaten food, detritus, organic matter, big particulates. And then this chamber, the water is trickling over. It's called a trickle filter. The water is trickling over this biofiltration media, and the idea, this is the main biofilter of the aquarium. Biofiltration is the process by which bacteria consume and detoxify waste, basically nitrogen waste. So when fish takes a poop, as soon as that turd starts to break down, it releases ammonia. And there's a strain of bacteria in there that eats the ammonia, turns the ammonia into nitrite, which is also toxic. Ammonia and nitrite are toxic. Then there's a second strain of bacteria that consume the nitrite and convert it into nitrate, which is relatively untoxic. And so there are bacteria that live in this condo down here, this biofilter. They're filtering the water of toxic nitrogen waste. And then, let's see, what else do we have? We have a couple of probes on there that aren't hooked up for detecting pH and for ORP, known as oxidation reduction potential, but that's for another talk. They're just water quality monitoring probes, and then we have our light fixture. This light fixture is T5 fluorescents. They're highly energy efficient, and they produce a ton of light too. Now you notice that we have a white bulb and a blue bulb. These fixtures these bulbs in this fixture were designed for growing corals to replicate sunlight. So as you see on the reef tank, it's a different type of fixture because the reef tank is deeper, and those types of bulbs are more intense. So they produce a greater quantity of usable light. On this tank, we just mostly need light for aesthetic reasons, just to make it look the right kind of pretty. Mm-hmm. The anemone tank and the coral reef tank, they need the light as a life support system. What's the question?
What was the name of the light bulbs?
These are a type of fluorescent bulb. They're called T5. So the old-fashioned fluorescent bulbs, the long tubes that were about an inch in diameter, those were T12s. And then they came out with T8s. And now we have T5s.
I have a question. Now, do those have two different types of light, like UVA, UVB?
Yes, they have two different types of light, and they have nothing to do with UV.
UV, nothing to do.
They have nothing to do with UV. That's a common thing that people see the blue and they think UV. I hear that all. I don't know what it is about
tanning beds or something.
Yeah, I think that's what it is. I think you're right. The blue bulb produces blue light, and blue light penetrates through water the best. In other words, water can't filter out that blue light. And that blue light, 420 nanometers on the spectrograph, is usable for photosynthesis. There's all kinds of light that is not usable.
Right.
The white light, is about 10,000 degrees Kelvin, and has this. That's the color temperature of the light. It's a fancy term for describing the quality of the light. The blue light is closer to like 15,000 Kelvin or 20,000 Kelvin, and happens to be like about 420 nanometer spike. If you go scuba diving and you go down any deeper than say 40 or 50 feet, everything looks blue to us. Because when you get down that deep, the water has filtered out all the other colors of light, and the only light that's getting down there is the blue.
Battery.
Question?
Battery.
Battery's dying? All right. So that's basically it. We have a pan here for catching any leaks so they don't go out on the floor. The chiller, the job of the chiller is to detect the temperature of the water. And here, point at me for a second. Here's the target temperature, say 60 degrees, because they're cold water animals. And the room here is, say, 70 degrees. With no chiller, and the pump adds heat, the tank would actually be running closer to 90 degrees. So the chiller keeps it down below the ambient air temperature at our target temperature. As soon as it starts to get warm up 1 degree above the target, boom, the chiller kicks on, chills it down, and then it turns off. And it warms back up, chills down. So the chiller keeps it from yo-yoing wildly, and keeps the temperature in the right target range. The heater would be the last piece of equipment, but here our main problem is overheating, so we don't have heaters on the tank. That's it. Huh?
Questions?
Questions?